Hello, everyone. You are welcome to today's meeting. And in today's session, we are going to continue from where we left off on the topic trigonometry. Okay, we are looking at what core math aspect, which is now math aspect of what? Of trig. Okay, in our previous meeting, we were looking at angles of elevation and depression questions. Okay, and I told you that usually, okay, it will come in a statement form. Sometimes the diagram will come with a statement and you will proceed. Okay, however, most often than not, okay, it's only the statement that will come, then you will extract the diagram and proceed with what? Giving the solution to what is being demanded in the question using the diagram. Okay, so let's look at, I think we solved up to from question 1 up to what? Up to 7. Today we are going to look at what? Question 8 and maybe, some few other questions. Okay, and after that, we'll look at how to find, okay, trig values of special, okay, angles. So that will be our target for today. So by the end of today's lesson, okay, you should be strong in terms of how to deal with angles of elevation and depression questions, okay, and also you should be able to know and find special angles, their trig, okay, values. Okay, so quickly, let's look at the question that we have right before us. So work example 8. We have two observers, P and Q, 15 meters apart. Observe a kite in the same vertical plane. Okay, so I'm going to underline this. At the end of the solution, I will ask you, maybe I'll give it to you as an assignment, go and find out. Okay, vertical plane, so I'm underlining this. The angles of elevation of the kite from P and Q are respectively 35 degrees and 45 degrees. Okay, find the height of the kite to the nearest meter. So you can see that there is also a required approximation. So you underline that, all in the quest of protecting our mass. All right, okay. So now, A, what are we supposed to do with this preamble? Okay, A, if P and Q are on the same side of the kite, so we need to find the height of the kite to the nearest meter. If P and Q are on the same side of the kite, then B, if P and Q are on the opposite side of what? Of the kite. So these were the two scenarios that we looked at, okay, in our previous meeting. When the observation is done at the same side, okay, or opposite side of where you are sighting what? Your object. So let's go and look at, so obviously you can see a skeleton of what? Of the diagram that will come up, because I don't want to waste time. Okay, this is something that we've done and we just want to solidify our understanding. So I'm going to explain how this diagram, okay, came about. Remember, we are told, okay, and this is not a full diagram, so we'll be adding, doing additions. So we know per experience, if your observation is done, and we are talking of angles of elevation, if the observation is done, okay, at the same side, then this will always be the picture. So per experience, you know. However, I will still explain so that those, okay, who still have issues, you can now, okay, be aboard. All right, so we are told, so let me assume my kite is here. So I'm sighting a kite. So a kite, obviously, because I'm talking of what? An angle of elevation. And here, the kite came with a name, so you cannot give it any other name. So where you have your kite, that's where your first point will be. Okay, then we are told that, okay, we are sighting this kite, okay, at P and what? At Q. Okay, we are sighting K, okay, at P and at Q. So it means, okay, we should be down before we can elevate to sight what? K, which is up. Okay, so obviously, I know that I'm going to get 2 points, but we are told that they are on the same level. Okay, only that here we are saying they are on the same vertical what? Plane. But you can see that what I've done here, I'm looking at it in the same what? Horizontal plane. Okay, I just want you to know that if it is vertical, it is horizontal, the plane, the observation is made, we are talking about the plane. If it is horizontal, Okay, am I answering the question that I want to ask you? Okay, so I almost answered the question. Forgive me. All right. Okay, so let me go by my point. So per the picture that we have here, this is what we are dealing with. Okay, so maybe P could be here. Okay, let me put P here, Q here. Then our Q could be here. These are the two possible positions for P and Q. Okay, however, remember, in our last meeting, we said that the closer you are to your object, okay, the bigger your angle of elevation. So that will inform us as to how best we can position these 2 points P and Q. So if you put P here, then it means, okay, that the angle here, okay, must be bigger than the angle here. However, let's look at the angle for P. The angle for P is 35. That is, if you are at P and you want to sight K, it is 35. So if you put 35 here, then obviously, okay, we know that the 45 will be here. So if you bring 45 here and 35 here, you can see that you have, okay, indirectly defeated, okay, what you've stated there will defeat the real life situation. The closer you are to your object that you are observing, the bigger your angle of elevation. So this goes to tell us that, okay, P cannot be here and Q being here. We have to swap. Is my point well made?
Yes, please.
Okay, all right. So on that note, I am going to clear that. Then we do, okay, the needful. Okay, so what do we have? We said in this case, if you look at the bigger angle, the bigger angle is for 35 is for P and what 45 is for Q. So it means Q must be positioned here and P equally here. So on this note, I know that this will be my 45 degrees, okay, angle, and this becomes what? My 35, okay, degrees what? Angle. All correct, my professors.
Yes, please.
Okay, so you can obviously see that's where you have your kite. Obviously, you have a vertical line now, a horizontal line. They will meet at an angle of 90. So don't forget to indicate your 90 angle there. And remember, I told you, it is always convenient to label all the vertices. So there is one vectors left to be labeled, which is this. So maybe I can call it A. Okay, or any letter of your choice. However, these three letters there, you can't change them because they came directly in the question. Okay, all right. So now let's see. Okay, we've indicated the angles, but you can see that there is an obvious side, okay, given that we have not indicated in our diagram. So 50 meters apart will be, 50 meters will be the distance between P and Q, because we are told that these two observers, okay, they are 50 meters apart. That's the distance between them. So P and Q, this distance here will be 15, okay, meters. All correct, my professors.
Yes, please.
Okay. So now, if you look at this diagram, okay, obviously, or I should ask maybe so that the class will be interactive, how many right angle triangles, okay, can we extract maximum? Right? I didn't say how many triangles. I'm specific. Right angle triangles. Two, is that not it? Okay,
yes,
two
please.
right angle triangles. So one will be, maybe,
K,
let me go for the small one, K.
AQ.
AQ, that's a small one, very good. AQ. And the bigger one will be K,
P.
KAP. My professors,
Yes,
I hope you
please.
are all with me.
Yes,
Okay,
please.
so that's what we have. However, okay, so in this case, let me indicate any known side or angle. I know this angle here to be 45. Okay, I don't know any side for now. Okay, I know this angle to be 35 degrees. Okay, I don't know any side, okay, for now, the length of any side for now. However, we will need the length of sides, okay, based on representation or whatever for us to proceed. So let's go and see how best we can introduce some side length. So now let's go. If I take, okay, this particular, what do you call it, side of my triangle, right angle triangle, I can represent this by X. So if this is X, then it means indirectly what I have here is also X. Is that clear?
Yes, please.
Okay, now if that is x, then we also know that if this is x, then the length of AP is known, and that will be s plus 15. Am I right?
Yes, please.
Yes, please.
So it will be s plus 15. Okay, maybe let me put it in brackets and indicate the unit. But here I'm ignoring the unit. So this is more or less my rough diagram. So what do I have? X, okay, plus 15. All right. Those who are matured, okay, can do the analysis without, okay, breaking the diagram down, okay, into these two simple, drawing these two. As for the breaking, you have to break it either mentally or you come and, okay, show. But as you are mature, you can, okay, do it mentally. So going forward, I will present it what the matured way so that you can equally adapt. So it means when we are giving the marking scheme, the diagram, okay, the marks will be given here. This will just be a helping diagram for you. Okay, we won't give any, okay, marks for this. So please take notes. Okay. All right. So at this point, remember, we said, okay, if you're able to break it down into the two in this case, simple diagrams that we have there. Okay, let's consider whether we have a common angle or a common wall side. Okay, so if you consider these two, okay, separate triangles, right angle triangle, you can obviously see that you don't have a common angle, you only have a common side, which is the side AK or KA. Can you see that? And that is what the question is asking us to find. My professors, are you with me?
Yes, please.
Okay, so let's represent that by h, like we have represented this one by x. So this will be the height. So let's use, okay, small h. Oops. Okay, small h for this. It will only help us to write less. So instead of writing the length of AK, okay, we can put h there. Okay, indirectly, we are also trying to say that this is h for those who would want to use only this one to do the analysis. So come and take the first diagram. Okay, so from the first right angle triangle, okay, we can say that we know this angle, we know, okay, this opposite side, though is in a letter, we know the adjacent side again in a letter. So this will be the side that we will need. So in this case, from triangle KAQ, comma, if you have space, you continue. Otherwise, you come down. But I am going to continue. So what do we have? Let's go. Opposite then adjacent. Which trig ratio?
Um, I'm twice. Okay.
Okay, so two. So
Second
it will be
twice, so
tan.
tan.
Tan,
Yes,
okay,
please.
45 degrees. My professors, I hope you agree, will be equal to. Okay, so now tan is opposite over what? Over adjacent. So the opposite will be h over the adjacent, which is what? X. All correct.
Yes, yes, please.
Okay, so remember we are forming our equation in H. Remember, if you have a common side, form an equation for the common side. If you have a common angle, form an equation based on what? The common angle. But here we have a common side. So I can confidently say my next step, I come close to the margin. So this implies that, okay, my H, okay, will be equal to, it's like I'm multiplying through by what? X. Multiply this by
Yes,
X,
please.
X will cancel, multiply. So I'll get X, okay, tan 45.
45.
Okay, very good. So time 45 degrees. Okay, so I label this one as equation one. Go and take the second diagram. Okay, so from, okay, our second diagram, and what's the name? So right angle, and that is what K,
AAP.
A, what P. Okay, again, comma. Okay, so that one, again, we have opposite adjacent, so it will be tan, okay, 35 degrees. Okay, it's equal to, here, let's go. Opposite, which is what?
Um, the
H
H over
over x
X
plus
plus
15.
15.
My professors, is everyone on board?
Yes, please.
Yes, please.
Okay, all right. Okay, so at this point, we should be so good to go. Okay, so now again, we need to have our equation in terms of h. So this implies that, okay, you are going to multiply, okay, this by this. So h will be equal to,
For the big
so
time.
h will give us, let's go. H will be equal to X plus what?
X
15 tan
15 times
25.
35
35.
degrees. Do you agree?
Yes, please.
Sure. So what I've written is what you write.
No, please.
So okay, I'm drawing your attention to some of the mistakes that you do that will cost you your mark. So what is supposed to be done for the meaning here to be the same as this meaning?
Sir, please to put the X plus 15 in brackets.
Yes, very good. What is multiplying your tan? Okay, your
Tan.
trig ratio is more than a 10. So always put it in brackets. So critical. Okay, so now that's okay. We've done the needful, okay, and we are on track. So we know 1 minus equation 1 is equal to equation 2. Okay, so comma. So this means if h is equal to this, then the same h is equal, then it means this must be equal to that. So it means I will get x tan, 45 degrees, to be equal to what? X plus 15,
Plus 15 all in brackets.
tan
35.
35 degrees. Okay, we are doing well. We should keep it up. Okay, so remember, we are looking for what? X. So if you are able to find X, you know H because H is in terms of X. So this equation is in X and we should be able to solve any equation in one variable. Okay, so at this point, what do? We go and expand the side, and later collect the terms, in X on one side. So if I am going to expand this side, I will keep the left-hand side as what? X tan what? 45 degrees. And that should be equal to what? X times this, which is
Tan
X
35
tan 35.
plus
Plus what?
15 tan 35.
Tan 35. Okay. So tan 35 degrees. So take note of that. I hope my handwriting is legible.
Yes, please.
Okay, great. All right. So now what do we have? Like I said, we need to collect the terms in X on one side. Remember the advice. Anytime you are doing change of subject and the variable that you are making the subject, you can find that variable on each side of what your equal to sign. Okay, it means you need to move. Check which movement will be ideal. And I told you that. How do you determine that? That will come from the number of negative signs. Okay, attach the terms that you get there. So the number of negative terms, throughout on both sides, if you put them together. Okay, so if you have less negative term, that will be the ideal movement. So if I move this one to this side, I know it is only this term here that will come here and be negative. These two terms here, one of them will be negative. The term remaining here will be positive. So I'll have only one negative term. However, if I keep this and move this one, this will be negative. I'll move this one also to this side. That will also be negative. So I will have two negative terms, one on each side. So it means the second movement will give me 2. The first movement, will give us what? 1. So it means we have to go for the first movement. All correct?
Yes, please.
Great. So on this note, what do? We are going to move this one to the side. So X, my professors, I hope you've taken note of that advice.
Yes, please.
Okay, all right. It seems it's only Prof. Martin who is responding. Okay, it's equal to what? 15
times 25.
Okay, 35 or 25? It's
35.
35. Okay, all right. Okay, so that will be equal to what we have there. Then at this point, you come and factor out your X. Okay, so it will be X tan. Let's go the whole class. 45 degrees.
Minus
the whole
35.
class. I don't think the whole class is only matter.
35 degrees.
35 degrees. Okay, and that will be equal to 15. Okay, tan 35 degrees. Okay, Prof. Michael.
Yes.
Sir, I'm sure I don't understand with the 35. It said, let's see, x tan 45 minus x tan 35 degrees is equal to 15 times 35. So please, where from the 35 degree?
Where from this 35? Which 35?
The last one.
This one?
Yeah, this one.
Oh, this one, you understand this line, this step. Do you understand this step? Prof. Michael, are you there? Do you understand this step?
Sir, please. Is
Oh,
the
you're like,
last one 35 or 25?
no, it's 35. There's no angle that is 25 here. All the angles that we are dealing with, okay, are 35 and 45.
Oh, okay. I saw it as 35. 25, that's what I was asking.
Okay, so it's 35. Take note. Okay, all right. So now, okay, we write it again and we divide. So that will give us x, okay, to be equal to 15
15 times
and the whole
35
class. Let's do it together. 35 degrees over
over
Tan
tan
45
tan,
45
degrees
okay,
minus
45 degrees,
minus
okay,
tan
minus
35
tan,
degrees.
okay, 35 degrees. Okay, so this will be calculator where I've told you after you've made your variable the subject, that's where you carry out your, okay, I mean the use of the calculator. Otherwise, if you approximate here, okay, later you come in approximate. So the more you approximate, the more you move away from the accurate answer. My professors, point well made. Okay,
Yes,
so
sir.
I will be relying on you for the value of x. So x will be equal to
35.0346.
35,
0.0346.
0346. I hope you check the next digit. So what do we write? It's in meters. Then we don't forget we've approximated. So we don't forget to indicate our approximation. And he knew that the first approximation should be 4 dB. All correct.
yes please.
Okay,
Yes,
very
please.
good. Okay. Wow. Okay, it seems I've exceeded my number. Okay, so now what do we get? Okay, so I can say that therefore the height that we are looking for. Oops. Okay. So what someone is calling. Okay, let me do the needful here. Okay, so now we're asked to find what do you call it? Height. So I know the relationship connecting the height. Let me go to, so connecting the height, okay, and x. So this is what we have. So you have two relationships. Remember this and that. Let me see if you can see the cursor. Okay. Oops, what is happening? Okay, no problem. I think we should be able to. So we have, okay, this relationship, okay, and this relationship, okay, for h representing your height. But remember I said, okay, always go for, okay, this one. Okay, if you look at these two relations, this is the prettier relation or prettiest relation. So please take note. We'll go for this one to find our x. Is my point well made?
Yes please.
No,
Okay,
please comment.
okay, I said, okay, your h, you are asked to find h. And when you formed your equation, you realize that you have two equations in two variables. So if I'm able to find x, I know h. And I said now we found x. So it means we know h. So it's either we come and substitute the x in this relation to find h or in this relation. However, if you look at these two relations, this is prettier than this. Okay, I mean, beauty lies in the eyes of the beholder. For me, this is prettier than this. I hope you agree. If for you this is prettier than this, that's okay. Go for this one. Is my point well made?
Yes please.
Okay, but okay, we should all agree that this is prettier in terms of its nature. It's very simple compared to this. This one has brackets and what have you. Okay, so that will inform us that this is the one that we need to settle on, okay, to find our h. Okay, so in this case, all right, therefore, they asked to find, so the height. Okay, so therefore, height of kite, or let me write kite height. Okay, which we labeled x will be equal to, sorry, h will be equal to our x that we found there, which is 35, okay, 0.0, Okay, 3, 4, 6. Okay, then it's tan what? Okay, if you go back, you see that the tan is what? The 45 degrees. So we are going to get 45, okay, degrees. Okay, so I'm waiting for you to give me your answer.
35.
Come again.
35.
Okay, because
35.
tan 45 is 1. Very soon you know a special angle. We will do that. Okay, so that will still give us the 35 point was 0, okay, 3, 4,
6.
okay, 6. Okay, but you know, okay, the length is in what? In meters. And here you didn't approximate. So at this point, remember, you can't end here. Remember, you end with a 4dp unless otherwise stated. Here it is otherwise stated. Okay, we need to end with the nearest what meter. So it means this will be equal to what? 35
5 meters.
okay, meters. Then you put in brackets nearest, okay, meter. Point well made.
Yes, please.
Hello, is everyone fine, my professors?
Yes,
Yes,
please.
please.
Yes, please.
Wonderful, wonderful. Okay. Okay, all right. So if that's the case, then now there is something missing. Who can tell me what is missing so far in my presentation?
Please, the question number.
Perfect. The question number. Remember, I've told you questions are numbered because your solution must be numbered. So the major question number is missing. Okay, that is what. And here, you know, once you did this, we were looking for A. That's why this diagram is there. Okay, point well made.
Yes, please.
Okay,
Yes,
so
please.
now let's go and look at the solution for B. Okay, so I should leave the B for you as an assignment. Okay, should we do the B together?
Yes, please.
Yes, sir.
I know, right? Okay, so let's see. So we are going to look at the B. Okay, so we'll move on to the next page because that's where I have my diagram. Otherwise, I would have continued. Yeah. So this is the picture for the B. So let me look at the B. So 8B. Okay, so 8B. So we are looking at a situation where okay, the P and Q are on the opposite side. So it means this is where you have your K. Okay, and P could be here. Okay, Q could be here. Here with this one, it doesn't, when they are on the opposite side, it doesn't really matter where you put your P and Q. And when they are on the same side, it really matters. Okay, I hope you are with me.
Yes, please.
Yes.
Okay, so take note of that. Okay, Prof. Benjamin.
Sir, please, in the question, it is kite, but why have you drawn this one? Triangle.
Oh no, the kite is an object. Oh, the object will be indicated by a point. So if let's say they talk about two, I said two observers, P and Q. Observers are human beings. Is that not it? But can you see me drawing draw any human beings here?
Nah.
No. So what you are looking for, so your human beings, what you are observing, you always see them as points. Is that
Okay,
clear?
sir.
Unless you want to
Yes,
draw a
please.
kite, you can go ahead and draw your kite. But it's not necessary.
Okay,
You get
sir.
the point.
Yes, please.
All right. Okay. So thank you. Now, okay. So K is here. So from P, if you want to side K, you need to move a certain angle, and your angle must be what we are told is what 35 degrees. Okay. From Q, you must side K, move a certain angle to side K, and that is 45 degrees. All correct.
Yes, please.
Okay, now there is one vector here which is not labeled. So again, let's call this A. Okay, the question is asking us to find the height of the kite. So in this case, okay, this will be 90. Okay, so always we are talking about what? The height will be any line from that point meeting the line that we have here at an angle of 90. Okay, that will be the nature of height. Okay, so this will give us what? H, which is the same as the altitude. Okay, so in this case, we know the distance between them to be 15 meters. So this is 15m. All correct.
Yes, please.
Okay. So with this one, I will not separate my two right angle triangles. I will work, okay, with what I have here directly without separating them. Okay, so if let's say I represent AP by X, then I don't need a rocket scientist to tell me that if the whole of this distance is 15 and this is X, I should know that the remaining distance will be 15 minus X. Do you all agree?
Yes.
Okay, so this gives us 15, okay, minus X. All correct.
Yes, please.
Yes.
Now the distance between A and Q. Okay, so at this point, once your diagram is perfect, the rest will be how best you can deal with your trig, your ability to, okay, manipulate, okay, trig, okay, functions. So in this case, let's go for the first one. So from, okay, my first, so you can see that I didn't separate them. I'm using this original or main diagram. Okay, so from my right angle triangle, and I said you can equally do that if you are matured. From right angle triangle KAP. Okay, comma. So we are going to get what? Okay, so this is the opposite to this angle and what? And this is the adjacent. So we'll still use tan. Oops. Okay. My professors, I hope you are with me.
Please.
Okay, so let's go. So tan, which angle?
Tan 35.
35 degrees will be equal to
H
opposite,
over
which is what? H over what? Over X.
X.
So this again will imply that your H will be equal to what? X tan
X.
35 degrees.
Tan
All
35.
correct.
Yes,
Yes.
please.
Please.
Yes, sir.
Very good. Okay, so this then becomes your first equation. So you label it as equation. And I've told you, avoid writing, labeling your equation this way, equation 1. No, this is not necessary. Okay, just click this. No matter how small the time that will be saved here, it will always be useful. Okay, how little that time will be saved. So now we go to the second triangle. So from, okay, our second right angle triangle, okay, which is what? KAQ.
Q.
Okay, comma. So that one too, opposite to this angle adjacent. So we use tan. So tan, our angle there is 45
H
degrees.
over
Okay, so it's equal to what? Your
H over 15.
H over 15 minus
15
X.
minus X.
Very good. Okay, so this is what we have. Okay, so at the normal circumstance, okay, if you have done special, okay, what do you call it? Angles and their trig ratios, you will know that this will be 1. So you can proceed. I'm going to proceed in that way. Okay, and after that, this will take us into, okay, that particular concept. So I'll write, okay, this implies that, okay, here, because if it's any other angle and it's not special and I will approximate, I will ignore. So tan 45 degrees is a specific value. That is 1. So I'm not approximating, so I'm going to write it there. So I will get 1 is equal to what? H over 15 minus. Should I come again?
No.
Yes. Sir.
Is my point well made? So
No,
just
please.
like this one, okay, those of us who are matured, okay, will do this. Okay, those of us who are matured, before I label, I know that there's a special angle, it will give me 45. So I will write H is equal to X. Then label that as what? 1. So it means if I immediately find X, I know H. But if it's any other angle apart from 45 and what have you, that one you approximate. Do you get my point?
Yes, please.
Okay, so very soon, if I give you your team assignments and what have you, some of these things, or you come together, then, okay, make use of all that I've given you so far. So now let's go to what we have there. So I can say that H now will be equal to what? 15 minus X. So immediately I find my X, I only use, so that will be my equation, or equation 2. Sorry. All correct, my professors.
Yes,
Yes.
please.
Okay, so in this case, I can comfortably come and write equation 1, I know is equal to equation 2. Because if H is equal to this and the same H is equal to this, then it means this must be equal to that. Okay, so at this point, let's go. We are going to get X
X tan 35.
tan 35
35
degrees. Don't forget your degrees.
is equal
Equal to
to
what? 15
15
minus.
minus x.
Okay, so now what do we do? Okay, we are going to collect the terms in x on one side. So I'll move this one rather to the side. Is that clear?
Yes, please.
So we get x tan
And
35 degrees. Okay, plus what? X. Okay, is equal to what? 15. So remember, you write it again. Oh, sorry, you factor out. I've not done that. X
into
tan.
bracket tan 35 degrees plus 1.
Very good. Okay, is equal to what? 15.
15.
We are doing well. Keep it up. So the next step will get x to be equal to, you write it again and you divide. So you get 15
divided by and 35 plus 1.
35 degrees plus 1. So here you can use your calculator to find the value of x. I'm waiting. So feed your calculator with 15 times 35 plus 1.
8.8225.
8.8225. 8.8225. Okay, remember, okay, x is length. Okay, so, and the length here we are looking at, okay, in meters. We approximated to 4 dp, right? We don't forget to indicate our approximation. Okay, so now, okay, now that we know x, we can go and find what? H. So I'll write there for h is representing the kite height. So kite height, okay, h, okay, will be equal to, remember we said it is what? 15 minus, as if you want to come and use this one too, you use, but now I can confidently say that this, okay, is prettier than this, because it doesn't involve any trig ratio. Do you get it?
Yes, please.
Okay, so I will use that equation 2 instead of 1 this time around. So that gives us what? Let's go. Okay, so 15 minus what? 8.8225. Okay, so you bring your units later. So that will be equal to
6.1776.
6.1776. Okay, all right, meters. Okay, Prof. Patricia.
Yes, sir, please. When you go to the x into brackets and 35 degrees plus 1, sir, please, where did the 1 come from?
This one. Oh, we factor out x. So if you factor out x, okay, you know, when you are doing factorization, if you factor out x, you get, because you are dealing with 2 terms, you get 2 terms in brackets. So you bring your bracket. Your first term, how do you get it? By dividing the whole of this by what you took out. So if you take s out, you'll be left with this. If you take s out, you'll be left with 1. Do you get it?
Yes, please.
Okay, so that's how come you have the 1 here. Take note of that. Okay, so now this is what we have. But can we end with this value?
No.
No. So if I'm underlying the salient part, so we are protecting our math. Before I move on to the next question, I check. Okay, I realize that no, I'm underlying nearest meter. So indirectly, a second chance to protect my maths. So nearest meter will be what? 6, okay, meters. Then I put in bracket. So or you can do this. If you use this sign, this approximate sign, immediately you use this approximate sign, you can choose not to indicate your approximation. If you use it, don't indicate, because you've already indicated that it is an approximated value. If you use the equal to, then you come on, indicate your approximation. Is that clear?
Yes, please.
Okay, so take note. You can use that, but you have to be very careful how you use it. Safa. Okay, very good. So if that is the case, okay, Prof. Benji.
Sir, please, how can the height be the A and the Q?
How can the
height be the A and the Q?
No, the height is not AQ. No, we are saying that here, what we have here. Okay, the 15, because this is 45, this is 90. So obviously, you should know that, okay, you are dealing with a special trap of triangle, okay, which will be an isosceles triangle. This will also be 45. So this side here will be equal to this side. If you get it, and the nature of the question.
Okay, sir.
Did
I
you
get
say
you, sir.
no?
Nah, no, please.
So that's the more reason why we can see that the height is equal to this.
Okay.
But not in every situation. If the angle here is not 45, there is no way two of the sides will be equal if you are dealing with a triangle, a right angle triangle. Safa.
No.
Oh, did I hear no? Okay, from where? From Patricia.
So the kite height.
Mhm.
So if written 15 minus 8.8225. So isn't it the 15 minus x? That's the a to the kill.
Yes, but we established here that the 15 minus x is the same as the h. You know the relationship now. The relationship gave us h to be equal to this. And I just said that if you have a triangle, a right angle triangle, you know one of the angles to be 45. You know that this will also be 45. Okay, once you have two angles to be equal, it means two of the sides will be equal. And that will be that this will be the base side. That will be the side, okay, that you have here. So this side and this side will be the same. That's the more reason why the relationship gave us that, okay, information that this side is equal to this side. Do you get it?
Yes, please.
Or the explanation is not clear to you?
No.
Oh, okay. So you establish a relationship. From your argument, you establish that h is equal to 15 minus x. So it means if I know h, I know 15 minus x. If I know 15 minus x, I know h. That's your relationship that we established here using the trig ratio. So it means this distance must be equal to the distance. And it makes sense, a clear sense. Because if you have a triangle, okay, and this angle is 45, this angle is equal to this angle, and this angle is 90. What type of triangle are you dealing with?
Isosceles.
No, Prof. Patricia, what type of triangle are you dealing with?
Say please, what triangle?
Which triangle will have two angles to be equal?
Say please, an isosceles triangle.
Isosceles triangle. Isosceles triangle will have how many equal sides?
Two equal sides.
So this angle here being equal to this angle basically tells that this side will be equal to this side. So that's the same information that you have here, only that the diagram is in this form. But you know that this angle here, okay, is equal to this angle. Therefore, this side will be equal to this side. So that's the more reason why h must be equal to 15 minus x. And that was established there. You get it?
Yes, please.
So the fact that this is in 15 minus x and this is h doesn't mean they are different. Okay, automatically. You get the point. They are represented. I could have called this maybe w, but I can say that w is equal to h. You get it?
Yes, please.
Are you sure you are now fine?
Yes, please.
Okay, all right. I saw another hand up, but I don't know whether, okay, the name just escaped me. I should have called you initially before calling. Please. Okay, or your question has been answered. I saw a different hand up. Okay, Prof. Hey, Abera. Lodina, I think you were the one that, Prof. Lodina. Then after that, I call you come in.
So please, when I solved for x, I had a different answer.
How? From where?
So please, 15 over tan 35 plus 1.
15 over tan 35 plus 1. Okay, so
Yes.
if you are saying that that's the situation, then let me equally find out, okay, from what you have there. So it means you are not giving me the right value. Okay, I want to use my, okay, calculator on my phone to check. Okay, please, who had the same answer as this? Okay, so then it's possible, Prof. Abera, you didn't feed it well with your calculator or the others. So let me find out myself. I will.
Sir, please. What Prof. Avera had, I also had that one.
Okay, so I'm going to do same. So that's what 15. I want to try with my calculator. So 15, then tan. Did you close the bracket? The tan 15. Did you close the bracket before bringing the plus 1?
Yes, please.
Sir, the same thing.
Prof. Abera, did you close the bracket? Okay, Prof. Abera, what did you get?
Sir, please, I solved it as it is.
Okay, so what did you get?
Sir, please, I had 20 plus 6 is 20.6.
No, I'm talking about the X.
Yes, that's what I had.
You had 20 plus
20.64 and 64572 and it follows.
Okay, so who gave me the initial answer?
Sir.
Prof. Abed, were you the one? Okay, so Prof, what do you call it? Abera, you capture your screen, your calculator, and put it on the class page. And the one who gave me this result, capture, I want to see how you fed your calculator to guide you because you are supposed to get the same thing if you did the right thing. Is my point well made?
Yes, please.
So that you learn, okay, the programming of your calculator. So capture and put it on the class page for me right now. Let me pause whilst I wait. Prof. Gideon,
Sir, please, but there's the side AQ is 15 minus X. So when you find your value for X, you subtract it from 15.
No, I'm only interested in the 8. That's what they are trying to tell me. We are only interested in the 8. If this value is wrong, H will be wrong. So let's concentrate on this for now.
So the value is the same.
It's the same as this.
Yes, please.
Okay, so you capture. I think there is she is saying that she didn't get this when she fed it with her calculator. Prof. Abera, Lodina, did I get you right or I'm wrong?
Sir, please, you're right.
You are right. Okay, so I said capture the screen of your and send it to me on on a class page. Put it on a class page so that everyone will get to see. And those who had this, one of you should capture and put it there for me. So Abera, that's why I said the bracket should come after the 35. They stand 35 here. That the plus 1, the plus 1 there is not the angle. The angle is this. So you didn't close the bracket. So that's the more reason. And she will be. So can you see that? I hope you can relate with what I'm saying.
Yes, please.
So the bracket should have been after the 35 before the plus 1. So it's more or less like garbage in, garbage out.
Yes, sir.
Okay. So take when even you should know. If which I know you are smart. If you get 20 for the X, you should know there's no making sense. Because if you do 15 minus 20 to give you minus 5, how can length be minus? So that should click that there is something wrong. Let me go back and check. Did you get the point?
Yes, please.
So, however, okay, so it means this question indirectly will help you. But if this was maybe 30 minus X, okay, and you had 20, if you don't take care, you wouldn't know that the answer there is wrong. Because if you subtract, you still get a positive value. You get a point. But here, fortunately, you should be able to make that determination. Is that clear?
Yes, please.
Okay, or detection. Okay, Prof. Frank.
Sir, please, when I solved the 15 over 10, 35 plus 1 on my phone calculator, it gave me 22.422. But on the calculator, I gave the value that you have here.
Okay, so it means check the programming of the one that you have on your phone. I hope you are with me.
Yes, sir.
So check the programming. All right. Okay. So if that's the case, then I guess we can have our water break here. We are done. The next concept that we'll be looking at. So now, when it comes to angles of elevation, where the measurement is taken at the same side, okay, or opposite to where your object is, you should all be able to deal with it. Okay. So please take note of that. Okay. So this will be, have your water break. By 37, you should all be back. Okay, so you are welcome back from the water break. And okay, so with this one, the angles of elevation, depression, we are done. Okay, you have other questions there, but it's either you see them in your team assignment. So let me continue and you see. Okay, so this is the continuation. Okay, so this one is either you see it in your team assignment or your class test. So make sure you practice. Okay, so now to our last concept under, okay, three. And that will be it for the entire, okay, lessons under trig for this particular vacation classes. All right. Okay, that is for core math, which is now mathematics. Okay, so we are going to look at the trig values of special angles. Okay, and for special angles, these are the angles that we consider, okay, special under trig. So please take note. Okay, the angles are 30 degrees, okay, 45 degrees. Okay, you just, okay, came from that. I mean, you were made known that 45 is a special angle and was 60 degrees. So these are the special angles. However, okay, there are other special angles, which will be the angles on the others. And by that, this is what I mean. Okay, let me squeeze that one here. But my concentration will be on the three that we have here. The others angle, okay, this is what we have. In trig, angles are measured, okay, anti-clockwise, anti-clockwise, okay, from the positive x-axis. So this is regarded as your 0 degrees. Okay, then you measure anti-clockwise. So 0, this will be 90 degrees, 180 degrees, okay, 270 degrees, and this, okay, 360. So all the others angles, which will be 0, 90, 180, 270, 360, are all special angles as well. Okay, but now we are looking at non-others, okay, angles, okay, that will be what? Special, that are special, which will be the 30, 45, and 60 degrees. Point well made.
Yes, please.
Okay, so you can see their values over here. So you should know their values offhand. Okay, however, I'm going to walk you through how we came by these values. Okay, and now even if you know, your calculator can give you the answers, okay, straight away, okay, in Z. At first, the calculators that you were using, if the answer is in Z, okay, it will give you decimal. So if the question says without using tables or calculator, and you go and use your calculator, will know, because you will leave your answer in terms of decimal. Okay, but now your calculator can give you directly the answers in Z. Okay, so even if you use your calculator and when you say without using tables or calculator, no one will know. Okay, but we need to know, okay, how to find these what angles. So quickly, let's, okay, look at the first, okay, two angles, which will be 30 and 60 degrees. Okay, that, I mean, two of the three angles, not the first two. If I say the first two, then that really means 30 and 45. Okay, so with this one, we say we are looking at an equilateral triangle of size 2 units. So it means this my equilateral triangle, this is 2 units, this is 2 units, this is 2. Is that clear?
Yes, please.
Okay. Now, because I have an equilateral triangle and I know the measures of the size, okay, the measures of the size can change. I'm talking about they can be the same side, but it can be 1 throughout, it can be 2 throughout, 3 throughout, any other value. Okay, but the angles will not change. The angles will be the same. So what will be the size of the angle, each of the angles in an equilateral triangle?
60 degrees.
60. 3 angles, so you divide by 3. 180 by 3, and that will give you. So it means I don't need the rocket scientist to tell me that this angle here is 60 degrees. This angle is also 60 degrees. Okay, and equally this angle is 60. My professors, I hope you are with me.
No, please.
Oh, equilateral triangle. This one is basic. You should know. Equilateral triangle will have an angle, okay, of each side 60 degrees. What is the sum of the interior angles of? Once it's equilateral, equilateral is the same as, in terms of angle, it says equiangular. Okay, so it means all the angles will be equal. So if I have the sum of the interior angles of a right angle triangle to be 180, and I want the size, okay, the three angles to be the same. I divide by 3, and that will tell me that each of the angles will be 60. Is that not it? So
Yes,
you should
please.
know automatically that a equilateral triangle will have an angle of 60 degrees each. As simple as that. This one, it should be quite basic JHS. Is my point well made now?
Yes, please.
Okay, very good. It's the measure of the size that can change, but for the purposes of what we are going to do, convenience sake, we are taking the size to be what, 2. It could be 1, 1, 1. If it is 1, 1, 1, the angle will still be 60, 60, 60. If it is 3, 3, 3, the angle will be 60, 60, 60. But I said for convenience sake, we are going to go for, okay, 2. And maybe further studies, you will know, okay, why we selected the 2 units. Okay, so this is what we are going to do. Okay, all right. I can see 60 as one of my special angles, but the other angle 30 you can't obviously see from this triangle, can you? We cannot. So what we are going to do is, because this is an equilateral triangle, if I draw a line from the apex to meet, okay, this side at an angle of 90, okay, that becomes the height of the triangle, which happens to be like a line of symmetry. Do you agree?
Yes, please.
Please, who doesn't agree? A equilateral triangle will have 3 lines of symmetry. I hope you know that.
Yes, please.
Okay, so each of them will be height. So the height will coincide with the axis of symmetry or line of symmetry. So this will be my height. Okay, then I know this height will bisect these 2 sides. I mean, this side, I should say, into 2 equal halves. That's why it's bisecting. Okay, and this line will equally bisect the angle. So it means this will be 30 degrees. Okay, and this 30 degrees. Do you agree?
Yes, please.
Hello, my professors. Are you with me?
Yes,
Yes,
please.
please.
Okay.
Yes.
So if the whole of this length, okay, is 2 units, and I have bisected, do I need a rocket scientist to tell me that the length here is 1 unit and the length is also 1 unit?
Oh, please.
Okay, so you agree, right?
Yes, please.
Okay, so this is what I'm going to do. I'm going to extract, because you can see that these 2 right angles are the same. This right angle here and this right angle here will be the same. Do you agree?
Yes, please.
Okay, so I'm going to extract only one of them and work with it. So let me extract it here. Okay, so now we know that this is 1 unit. You know that this is 2. Okay, you know that this is 60 degrees. Okay, you know that this is 30. All correct.
Yes, please.
Yes, please.
Okay, we could have as well done our analysis from this main one. Okay, but because the diagram is clumsy, that's why I've done that. Okay, so we know our trig ratios. So now let's go and look at what? The angle 30. Okay, so if I'm finding my trig ratio for this angle 30, then I have to know all the size. Okay, so that I can involve all the trig ratios. So now I know this is hypotenuse. This is 90. I know hypotenuse and I know what what do you call it? This side, I don't know whether it is adjacent or opposite, depending on the side. So I know this side and this side, but I don't know this side. But we can confidently find this side. So what I'm going to do is I want you to use Pythagoras theorem to find the side. Okay, then, or let's do it together, maybe to refresh our minds. So by the Pythagoras theorem, you could. So by the
Pythagoras.
Pythagoras is capital P, so don't forget Pythagoras. So Pythagoras. Okay, so apostrophe comes after the S, not before. Theorem. Okay, we know. So I'm going to find, let me call this H. Okay, so that if you are smart, I will know that my H, I'm being smart, okay, squared will be equal to this one squared minus this one squared, because 2 squared must be equal to, so let me write it so that, okay, sometimes if I skip some of these things, some of you who are not that matured, maybe you will not find it pleasing. So I know that 2 squared, okay, should be equal to what? A squared plus 1 squared. Do you agree?
Yes, please.
My professors, are you with me?
Yes, please.
Okay, so this will give me 4 is equal to A squared plus 1. Okay, Prof. Gideon.
I said, please, when you were extracting the right angle triangles from the main equilateral triangle, these from the first right angle triangle, the adjacent. No, sorry, the adjacent. Yes. So please,
No,
why
you
did
can't mention adjacent or opposite without mentioning the angle. Because if you say adjacent and you are taking this as adjacent, then it means it's relative to the 60. But relative to the angle 30 degrees, it is not the adjacent. So remember, I've told you the adjacent and the opposite are not fixed. The only one which is fixed is the hypotenuse. So if you are mentioning adjacent opposite, let me know the angle that you are referring to, because that is always relative to an angle. All correct.
Yes, sir. So please, using angle 30 degrees, the opposite.
Mm-hmm.
So please, that side. Please, can you come again? Why is 2? Why that side is 2?
No, it's not 2, it's 1. Okay, only that maybe I wrote the one that way. It's 1. So let me,
Okay, so please,
that by said that, okay, it's 1. Maybe because I gave my one that type. So let me write it like the usual one. Okay, so this is 1. Okay, this is 1. Is that clear now?
yes, sir. Thank
Yeah,
you.
so that's why you can see 1 here. Okay, so on this note, can I say that my h, squared will be equal to 4 minus 1, which is 3. Do you agree?
Yes,
So can I
please.
say that my h will be equal to root of 3?
Yes, please.
Okay,
Yes.
so I know that this is root of 3 now. I equally know that this is root of 3 now. Is that clear now?
Yes, sir.
So
No,
once I
please.
know, did I hear no?
Yes, please.
Okay, from who? Prof, what do you call it? Patricia or Portia?
Patricia.
Patricia, where lies the problem?
Sir, please, what you are doing?
Please, we are finding only one side of a right angle triangle. That's Pythagoras theorem. We did Pythagoras theorem when we started the trig. So that video is still available on your previous class page and also on my YouTube channel. Okay, we are not doing Pythagoras theorem, so I will not allow Pythagoras theorem to take our time because we've done that one already. That was the first lesson that we did under trig because I told you that you will need it. So please go and revise. Okay, unfortunately, I wouldn't be able to go back. All right, okay, other than that, if you have not done it, fine, I will go back. But once we have done it, I won't allow, you to take us back. It means you are not revising, okay, and you cannot, give us that burden to always help you or use us as your revision manual. All right, okay, so this is what we have. So h will be equal to root of 3. Okay, so once I know the measures of all the sides, I'm more than able to find my trig ratios involving the angles 30 and 60. So let me start with the first one. Okay, sine, 30 degrees. Sine is which ratio over which ratio? I mean, which number over which number? Sine is so opposite. If we are looking at 30 degrees, this is our 30 degrees. Okay,
1 over
opposite is what? 1. Okay, so opposite over hypotenuse. Hypotenuse is what?
2.
2. So that is this value that we have here. Is that correct?
Yes, please.
Okay, now let's move on to the next one. Okay, so cos 30 degrees. Cos is what? Adjacent over hypotenuse. Is that
Adjacent
not
over
it?
hypotenuse. Yes,
So
please.
relative to the angle 30 degrees. This is our adjacent, which is what?
Root 3.
Okay, root 3. Do you agree?
Yes, please.
Okay, over hypotenuse. What is our
Over 2.
hypotenuse?
2.
2.
2.
Okay, that is what we have here. All correct.
Yes,
Yes, sir.
please.
Okay, now let's look at tan. Okay, so tan 30 degrees. Okay, tan is what? Opposite over adjacent to 1. So what is opposite?
1.
Opposite is 1.
Okay, what is the adjacent?
Adjacent
Root
is
root
root 2.
Root 3. But remember, we cannot leave a fraction with a z in the denominator. So it means you have to rationalize. If you rationalize, we are going to get times root 3 over root 3. So that will give us root of 3 over 3. Is that clear?
Yes.
My professors, are you with me?
Yes,
No,
please.
Yes, please.
Oh,
Come again.
if you rationalize 1 over, you cannot leave a fraction containing a z in the denominator. I taught you rationalization last vacation. Okay, so which will give us times root 3 over root 3. So that will give us 1 times 3, which is what? 3. Then root of 3 times, so 1 times root 3, which is root 3. Then root of 3 times root of 3. That will give us root of 3 squared, which is what? 3. 3. Is that clear?
Yes, please.
So that gave us that. So I'll feed your calculator with 1 over root of 3 to give you the rationalized version, which is this. Is that clear?
Yes, please.
Okay, so now we are left with the 60. We've done the 30. Okay, 60, we can get it from this as well. So let's look at sine, okay, 60 degrees. Okay, that will be equal to sine is, so with respect to 60, this is what the opposite and this is the adjacent, you agree. The hypotenuse is always fixed. Okay, so what is the opposite?
Root 3 over 1.
Root 3
Over 1.
over 1, which is equal to?
Root 3.
Root 3. Any number over 1 is the number itself, so root 3. So that's exactly what we have here. Where is it? Sine. Hey, where is it? 60. Okay, so where is sine 60? Hey, please check
It's 3
again.
over 2.
So it's over 2. Okay, you are proving to be not reliable, so I'll be careful this time around. Okay, so okay, so let me clear that. Are we on board now?
Yes, please.
Okay, so
I
be
get it
careful.
now.
You get it now. All
Over
right.
hypotenuse, rather.
It's
Yes,
over
please.
hypotenuse, so I don't know where you picked the one. Okay, so now that will give us what we have here. Exactly.
Yes, please.
Okay, now let's look at cos 60. Okay, 60 is what? Cos is what? Adjacent over hypotenuse. So if
Adjacent
you
over
take this,
hypotenuse.
our adjacent is what?
1.
1. Our hypotenuse is what?
2.
2. So that gives us what we have here. Then the last one for this particular diagram, that will be what? Tan. Okay, 60 degrees. My professors, I hope you are following.
No, please.
Where lies the problem? So this is what we have. I'm not going to belabor the point. You have this diagram. Okay, 90. This is 60 degrees. Okay, this is 30 degrees. Okay, and this side is 2. This side is 1. We found out that this is root of 3. Now you are supposed to, the trig function, how to find the trig ratios. So use the trig ratio to find, that's where we are coming from. We build up to find, okay, sine 30 cos 30 tan 30. Okay, sine 60 cos 60 tan 60. That's all that you are supposed to do with this diagram. If you are not getting it, go back and revise. Okay, because we cannot always be going back. Okay, I taught you, and Prof. Caroline, you were under my voice that session. So if all that we've learned, we've left it in school or wherever, okay, unfortunately, I can't go back. Please take notes. We are burdened on, so that's the more reason why you need to equally always, okay, revise before you come on board. So here, I'm only guiding you to do that. So tan is, we've done, okay, tan, we know trig ratio cos, okay, sine. Tan is opposite over what?
Adjacent.
Adjacent. So if with respect to 60, we said opposite is root of 30, root of 3,
Root of
adjacent
3.
is what? 1.
1.
Okay, so we are going to get root of 3
3
over 1.
on 1.
Okay, which is the same
It's
as root
3.
of 3. So that's what we have here. All correct.
Yes, please.
Yes,
Okay,
please.
very good. Okay. All right. So now let's move on to the next one, how to get the 45. Okay, and after that, we'll give you special connection that if you know cos 30, you know that's of the sign of what the corresponding angle. So definitely I will see you notice a certain relationship and I'll guide you as to how to deal with that. So now let's move on to the next one. Okay, so unfortunately, it seems time will not allow us to go through the solution together. Maybe I have to record that one and send it to you. Okay, certainly. So let's go through what we have here. So For the 45 degrees, we will consider, let me even put this
Diagonally.
one here. Oops. Let me put this one here. This one is for the 60 degrees. Okay, then what's 30 degrees? So I should have written 30 degrees and 60. Okay, doesn't really matter the order. Then this one will give us the special angle of 45 degrees. Okay, so if you are looking at a square, we know that this is 90. Okay, this is 90. Okay, and if I pick my diagonal, my diagonal will be an axis of symmetry, true or false?
Yes, please. It's true.
It's true. Okay, so I said, okay, offside 1 unit. So this is 1, this is 1, this is 1, this is also 1. Okay, I know that this is 90. This equally will be 90.
90.
Okay, so now if I know that this is my axis of symmetry, okay, the axis of symmetry that I have here will equally bisect, okay, this angle, just like the other one. So if the entire angle here is 90, I don't need the reference scientist to tell me that this will be what, 45 degrees. Okay, 45. Or like I said, since these two sides are equal, it means the base angles must also be equal. So the base angle, if I sum, I should get 90. So I divide by 2. So that will give me 45 here, 45 here. You can also understand it from that perspective. All correct.
Yes, please.
Okay, so now let's look at, okay, we need to go and find the measure of the side. So by the Pythagoras theorem, if you do that, you know, this is the hypotenuse. Your hypotenuse squared will be equal to 1 squared plus 1 squared. So the hypotenuse squared will be equal to 1 plus 1. So it means your hypotenuse will be equal to root of 2. Do you agree?
Yes, please.
Professors, are you with me? This is just Pythagoras theorem.
Yes, please.
Okay, all right. So now this will give us root of 2 here. So we know indirectly this is a triangle that we are going to work with. Oops. So that's why I didn't want to. So let's see. So the triangle that we are working with will be this. Let me see if this will be better this time around. Okay, all right. So this is the triangle, and it's a right angle triangle. Okay, so this is 90. Where I have my 90, I have this to be 45 degrees. Okay.
45.
Okay, so I'm only interested in 145. That's okay. If you want to use this 45, you end up getting the same result anyway. Okay, so this side is 1 unit. Sorry, root of 2 units. This side is 1, this side is 1. Do you agree now?
Yes, please.
Okay, so in this case, if I come and write sine 45 degrees, that will be equal to
Opposite over adjacent.
opposite. So if I'm looking at this 45, okay, the opposite is what?
Hypotenuse. Opposite is 1.
1 over the hypotenuse. Hypotenuse is what? Root of 2. Now remember,
2.
you cannot leave a fraction containing a set
Yes,
in the
please.
denominator, so you need to rationalize. So it will be the numerator times root 2, the
Root of
denominator
2.
times root 2. So that will give us what? Root of 2 over 2.
2 over 2.
Okay, so that gives us what? The value that we have here. All correct.
Yes,
Yes,
please.
please.
Okay, now let's go and look at that of the cos. So cos, okay, 45. Okay, will give us, cos is what? What is our adjacent?
1.
1.
Okay, over
And
the hypotenuse.
2. Then root of
Okay,
2.
root of 2. Okay, so again, that one too, if you rationalize, you end up getting what? Okay, root of 2 on 2.
Root
All
2.
correct.
Yes, sir.
Okay, so that gives us this value. Afa.
Yes, please.
Okay, and the last but not the least, tan. Okay, tan 45, which we all knew before we came here that it will give us 1. Now let's see, tan is
1 over
what?
1.
Opposite over
1.
what? Okay, so opposite is 1,
Adjacent.
adjacent is 1. So we
1.
end up getting what? 1. So
1.
that gives us this value. Afa.
Yes,
Yes,
please.
Okay, so that explains, okay, the values that you have there. So those of you who are not following, fortunately, when I share the video, okay, pause where you need to pause and learn at your own pace. Okay, where you don't get a particular concept and you know that there is a prerequisite which we have done. Okay, you can stop, go and watch that video, perfect your understanding before you come and continue. Okay, now this is a very, important information that you need to know. Okay, you can see that we have sine, okay, and cosine. Is that not it?
Yes, please.
Okay, sine of an angle theta, then cosine of an angle theta. Okay, cosine has sine in it. Can you see that?
Please.
Okay, and take note. The co that you see there is just representing a short form of complement. Okay, so complement of sine. So it means, this is it. If I have two angles, theta, okay, and maybe alpha, or let me do alpha. Okay, if they add up to 90, complementary angles add up to 90, is that not it?
Yes,
Yes,
please.
please.
Okay, so this means if I know sine, okay, of maybe 30 degrees, I should know, okay, cosine of the angle that complements 30. And which angle complements 30? Which angle do you add to 30 to get 90?
60.
60 degrees. Check from the table whether they are the same.
30 and 60.
Sine 30 is what?
1/2.
Half. Okay, then what is what cosine or cos 60?
Half.
Half. They are the same. Is that not it?
Yes, please.
Yes, please.
Okay, so take note again. Okay, if I have, okay, sine 45 degrees, what would that be equal to? To be equal to cos what? Which angle will complement 45?
45.
45 degrees. So check whether sine 45 is equal to cos 45. Sine 45 is what?
Root 2 over 2.
Root 2 over 2.
Okay, cos 45.
Root 2 over 2.
They are the same, is that not it?
Yes, please.
Okay,
Yes.
and take note. Okay, so usually what I tell my students is to do is if you want to memorize, just memorize the first line. If you memorize the first line, okay, the rest you are okay. Because if I know sine 30, I know cos was 60. If I know sine 45, I know cos was 45. I hope if I know sine 60, I know cos 30. And if you study it carefully too, you can see, okay, if you write it this way, when you come here, you see that it's like you are writing backwards from here. Can you see that?
Yes.
However, if you know these two, sine and cos, you can get tan. Okay, because you know the ratio that I told you that tan, okay, theta is equal to what? Sine theta over cos theta. That's basic identity. So it means if I know sine 30 and cos 30 and I want to find tan what 30, I have to divide sine 30 by cos what 30. So do 1/2 divided by root of 3 on 2. It should give you this. Is that clear? If you come and do this over that, obviously you can see that it will give you 1.
Yes, please.
If you do this over this, it should give you this. So that's the more reason I said if you learn the first line, you know the second line, and you know the third line as well. Afa?
No.
Yes, please.
Point well made.
Yes, please.
Okay, all right. So I guess that will be it, okay, for today's, okay, meeting. So on that note, I would want to say thank you very much. Please don't forget to subscribe, okay, to my YouTube channel, share and like, okay, for more educational or education consults, content like this, forgive me. Okay, so on this note, that brings us to the end of today's, okay, lesson.